let's continue solving inequalities as we were doing. This time, however, we have to also draw graphs of the solution sets of these inequalities. And this is the next one. If you recall, we did till number 16. So this is the 17th one. 3x minus 2 is less than 2x plus 1. So the inequality is pretty easy to solve, but because we have been away from these things for quite some time due to Diwali and firecrackers, so I am adding extra steps. So you have the inequality 3x minus 2 less than 2x plus 1. So in the next step what we do, we subtract 2x from both sides, or you can view it this way also, we are adding minus 2x to both sides. One of the rules for manipulating inequalities allows us to do so. And we do this to get rid of 2x on the right hand side. So we have 3x minus 2 minus 2x less than 2x plus 1 minus 2x. Now 3x minus 2x, it becomes x minus 2, and on this side after cancelling 2x and minus 2x you are left with 1. So this way we have isolated x. We haven't quite isolated x completely, but at least we do not have x on this side. So now we have x minus 2 less than 1, and then to really isolate x, we add 2 to both sides. That also we can do, same law. You can add any real number on both sides of an inequality. So by doing that, this is what we get, x is less than 3. Note one more thing, that I am using double implication. I am not writing simply like this. What is the reason? We talked about it before, but let me again say what the reason is. If you just simply write ordinary implication, say I wipe these things once more. What does it mean? It means this: if x is a real number that satisfies this inequality, then x has to be less than 3. But what about the converse? Are the real numbers that are less than 3 also satisfying this inequality? Yes, actually that's also true. That's because you can go back from this inequality to this one by following the exact reverse steps that we followed in getting to this one from this one. And that is also allowed. Okay, you have to be careful of that. That just merely blindly writing double implication does not work, of course. You should really be able to go back. Just think of it for a moment. Say you start here, x is less than 3. In order to get to this, what is it that you should do? What did you do to get to this from this one? You added 2 to both sides. So now you add minus 2. You do the exact opposite. Okay. So if you add minus 2, on this side you will have x minus 2, and on this side you will have 3 minus 2, which is 1. And like that you can get back to that original one also. So these equivalences or the double implications tell us that these are statements, right? These are some sentences which are either true or false. All these statements are equivalent to one another. If any one of them is true, then all the others are also true. That is why if x is a real number satisfying this inequality, then x is less than 3, and also conversely, if x is less than 3, then this is true. That means if this is true, then this is true, and if this is true, then this is also true. And that is why the solution set is precisely the set of real numbers that are less than 3. And you already know that those real numbers form this interval minus infinity comma 3, and the interval is open on the side of 3 because we have strict inequality here. So this is the solution set. This is the set of precisely those real numbers that are solutions of this inequality, that solve this inequality. If you pick anything from here and substitute that here in place of x, you will get a true statement, which is this inequality. If you pick a real number from outside of this, then this will not be true because of the equivalence of this and this. You can test it for yourself. 3 itself, for example, is not inside this set. Now, if you choose 3 as a value for x, you can see, I leave it to you to verify that then the inequality will not be true. So, this is our solution set, and now we need to draw its graph as well on the real line. And the graph of the solution set is this. We need those points that represent the real numbers which are less than 3. And all those points, first of all, you have to locate 3 on the real line, which is somewhere, right? Say here. And then you locate those points which lie on the left side of 3. So those points constitute this ray, which starts here and of course goes indefinitely to that side, and that is why this part has been made thicker, it's bold than the entire real line. And the reason for drawing a small white circle here is that 3 itself is not a part of this graph. In order to indicate that, we have drawn a white circle. It's a rule. Okay. It means that 3 itself is not included. Had 3 been in the set, you would have drawn a black circle. Okay, so that's the entire thing. Next we have number 18, where the inequality is this: 5x minus 3 is greater than or equal to 3x minus 5. So in the solution we consider the inequality, we write it first. 5x minus 3 is greater than or equal to 3x minus 5. And here we are not going to supply that many steps. You can already see what we did. We subtracted 3x from both sides, and simultaneously we also added 3 to both sides. Those two things lead to this. It may look confusing at first, but the more you practice, the more you will likely do just this instead of writing 2 or 3 intermediate steps. If you still find it a little confusing, you yourself write those steps and you will get it. Okay, you do it yourself. So 5x minus 3x then becomes 2x, and 3 minus 5 is of course minus 2. And then in the next step we divide both sides by 2, or multiply both sides by 1 divided by 2. Because this number 1 divided by 2 is a positive real number, so the inequality retains its direction. It does not get flipped. But whatever I said just now is simply us coming to this from there. But can we go back? Unless you make sure that we can really go back, you cannot use this double implication. If you start from here, what should you do to get to this? You multiply both sides by 2 this time. We divided by 2 to get to this from there, so now we have to multiply by 2. 2 is also positive, so the inequality will maintain its direction. And 2x, of course, you can write 2x as 5x minus 3x, and in place of minus 2 you can write 3 minus 5. And to get to this from here, you have to follow those 2 steps. I mean, not exactly those steps, but they are opposite. So you can go back, and that is why the solution set is precisely the set of those real numbers that are greater than or equal to 1. And that is why you have this interval. Because, greater than or equal to minus 1, not 1. Because minus 1 is also now a possible value for x, so we have the interval closed on this side. Closed minus 1 comma open on the side of infinity, of course it's open. And now we are going to draw the graph as well. and the graph is this. It consists of all the points which lie to the right of -1 along with the point which represents -1, because that is the solution set. And next we have 19, where the inequality is this: 3 times 1 minus x is less than 2 times x plus 4. So we consider the inequality, and first we do the multiplications. 3 minus 3x is less than 2x plus 2 times 4 is 8. And then we gather all the terms having x on one side and push everything else to the other side. And we add 3x to both sides for doing that. So that way we get 2x plus 3x, but simultaneously we also add minus 8 to both sides or subtract 8, any way you can view it. And that way we get 3 minus 8, and there is no more 8 on this side. So this becomes minus 5, this is 5x. And then we divide both sides by 5. Because 5 is positive, so division does not affect the direction of the inequality, it remains the same in the same direction. So that way we get this, and I leave it to you to check that we can go back from this one to the original one, and that is why the solution set here is this open ray. We call an interval a ray if it is open either on one side or on both sides. Otherwise it's just an ordinary interval. It's open to the right, so that is why it's a ray. And it's the set of those real numbers precisely which are greater than minus 1. And because minus 1 itself is not included in this set, so open on this side. And now we are going to see the graph. You can see the graph almost, it's almost like that. And the graph is just that. The only difference is that now minus 1 is not included. Everything else is same. And then we have number 20. This is much more complicated, so I have kept enough space for it. X divided by 2 is greater than or equal to 5x minus 2 divided by 3 minus 7x minus 3 divided by 5. So we consider the inequality. The reason it looks so complicated is these fractions. To get rid of these fractions, what we do, we take the product of these denominators, which is 30, and then we multiply both sides by 30. So then 30 divided by 2 is 15, 15x is greater than or equal to 30 divided by 3 is 10, 10 times 5x minus 2, 30 divided by 5 is 6, minus 6 times 7x minus 3. So, well, we have to do long, I won't say long multiplications, but the numbers are a little big, but we can handle that. It's better handling these multiplications than handling the fractions. So 15x is greater than or equal to, let's do the multiplication carefully. 10 times 5 is 50. 50x minus 2 times 10 is 20. Minus 6 times 7 is 42. So minus 42x minus 6 times minus 3 is plus 18. So you can already see that it will ultimately become small, because 50x minus 42x, which is 8x, and minus 20 plus 18 is minus 2. So suddenly the complexity is, it has gone down, right? And then you subtract 8x from both sides, that way you get 15x minus 8x, that is greater than or equal to minus 2. So 7x is greater than or equal to minus 2. And then you divide both sides by 7, which is a positive real number, so the inequality will not get flipped. So that way you get this. And again here also, I am asking you to verify the steps, or actually think of them yourself, that will take you from this inequality back to the original one, to this one, okay. So you see that part. So this is our solution set. It consists of precisely those real numbers that are greater than or equal to minus 2 divided by 7. That's why this. And because this number is also included, so the interval or the ray is also an interval after all, is closed on this side. And now we will draw the solution set. And the graph is this. You already know why it looks like that. All the points which are to be in this graph should represent the real numbers that are greater than or equal to minus 2 divided by 7. So most of them will lie to the right of that point which represents minus 2 divided by 7. So that's why the graph looks like this, and this circle is black because minus 2 over 7 is also a solution of the original inequality.